Hello everyone, welcome to our video tutorial series on microcontroller. So you are watching this video to learn about microcontroller or at least want to know what is this thing that people around you are talking about. Before talking about microcontroller, let's start with something that you already know about. That is a desktop or laptop computer. If you open the casing of your computer and look inside, what you will find is this. This is a picture of a motherboard from Gigabyte. All the external devices like a monitor, keyboard or a printer are connected to this motherboard. At the heart of the motherboard is the CPU, where the microprocessor goes. It acts like a brain of the computer, which performs all the arithmetic and logical operations at an incredibly high speed. Next main part of the motherboard is the chipset. It acts like a communication device between the microprocessor and the external devices. So what are the external devices that must be connected to the microprocessor to perform its operation? First is the RAM, which is a volatile memory. The microprocessor alone is a dumb device. You need to give it instructions to operate. These instructions are stored in the RAM, and microprocessor read or write the RAM and follow these instructions. Next is the hard disk or non-volatile memory. Its job is to keep your programs stored, even if there is no power. When you run a program, it is loaded from hard disk to the RAM. And the last part is the peripherals, where you can read or write other slower external devices like USB, keyboard, monitor, etc. There are many other features in the motherboard that I don't need to mention here to understand microcontroller. Now you already know what this microprocessor is capable of. From playing of high-end video games to the simulation of an aeroplane can be done with this processor. It is capable of performing multiple tasks at the same time. But what about if we want to do a small specific task like controlling the temperature of a microwave oven? It would be absurd if we use a computer to do so. What we need is to bring this whole motherboard containing hundreds of ICs into a single chip with a lot lesser capabilities so that it can perform only one task at a time. Thus comes the idea of microcontroller. Inside the microcontroller, you will find a CPU or a processor much slower than the microprocessor of your desktop computer, an SRAM, a non-volatile flash memory, and some peripherals. For example, let's see the block diagram of AVR microcontroller architecture. Here we see that it has a CPU that does the processing. Like hard disk, our program is stored in the flash memory. The SRAM replaces the RAM of your computer. All the global and static variables of your program is stored in SRAM. And finally, we have some peripheral modules to communicate with the outside world. The size of SRAM and flash memory and the number of peripherals vary from model to model. So, the basic flow of operation is: first you write your program in your favorite language like C or C++, then compile the .c file into machine language and load it to the flash memory. When you power the MCU, the CPU looks into the flash memory and follows your instructions that you have written. Suppose we have written some instructions to drive a LED connected to an input-output module. The CPU will decode your instructions and use the control lines and I/O lines to control that I/O module and thus drive the LED. There are many microcontrollers of various size and speed from various vendors. Each has its own advantages and disadvantages, but we will focus on microcontrollers of Atmel because of its high speed, variety, and a large internet community to get help. Atmel produces from teeny 8-bit microcontrollers to high speed and high performance 32-bit microcontrollers using ARM processors. But to start with, I prefer 8-bit Mega or X Mega microcontrollers. You can visit Atmel's website and compare the features of various microcontrollers. Now let's discuss how you can take your project from planning stage to a final product. Here are a few steps that you have to go through regarding your microcontroller projects. You may have to perform steps 1 to 4 over and over again until your project gives the desired result. First, you need to decide which features of your microcontrollers are required for your project. Then choose the appropriate microcontroller. Draw a schematic connecting the peripherals to the proper pins of microcontroller. For a schematic drawing, you can use Proteus. It has several other features like simulator, debugger, PCB designer, etc. These are both commercial tools. For free tools, you can use Express PCB. This is the step where you will spend most of your time during your project. We will use AVR Studio 5 IDE, which is developed and maintained by Atmel, and it's free. There are several languages to write your program for your microcontroller. AVR Studio supports assembly and C or C++ language. It supports all the AVR family microcontrollers. You can visit the YouTube channel of Atmel to watch the video tutorials on AVR Studio 5. There are some commercial tools available also, like CodeVision AVR, IARC compiler, microC for AVR, etc. You can use Proteus Virtual System Modeling or VSM to simulate and debug your AVR code. Though it does not support all AVR microcontrollers, it can greatly reduce your development time and cost using common AVR microcontrollers. You can also simulate your code using built-in AVR simulator in AVR Studio 5. But if you are not satisfied with this and want to see what is really happening inside the microcontroller in real time, then you can go for a hardware debugger like Atmel AVR 1 or AVR Dragon. Now, if you want to test your project in hardware, what you will require is a programmer. Using a programmer, you can load the hex file, which is generated by the compiler, into the flash memory of your microcontroller. For programming the flash memory, you have two options: serial programmer or a parallel programmer. The programmers listed here are serial programmers. It is easy to use a serial programmer as it does not require any high voltage supply. There are many USB versions of this serial programmer available in the internet. For example, USB SP and USB Tiny ISP. You can easily build these programmers using a microcontroller and some basic components. Here, this site has the detailed documentation on how to make USB SP programmer. It has enlisted the schematic, code, and supported softwares for USB SP programmer. Now, if your project works perfectly, you can move to the last step and make a printed circuit board or a PCB. You can use Proteus Arrays or Eagle PCB for this purpose. Or if you are looking for a free tool, then use Express PCB. This concludes our first tutorial. Thanks for watching this tutorial.